Hey everyone, welcome to Data Engineers Launch number 77. We'll give everyone a couple more minutes to file in. Hey everyone, welcome to Data Engineers Launch number 77. We'll give everyone a couple more minutes to file in. Hey everyone, welcome to Data Engineers Lunch. We'll give everyone a couple more minutes to file in and we'll get started soon shortly. Alrighty, let's go ahead and cut the music. Hello everyone, welcome to Data Engineers Lunch number 77. Today's topic is going to be on Apache Arrow Flight SQL, a universal standard for high-performance data transfers from databases. Today's talk is going to be given by Alex Merce, who is a developer advocate at Dremio. This is Alex's third talk here at Data Engineers Lunch. So if you're interested in all the various other talks he's given, you can find those on the Data Engineers Lunch playlist. I believe his last talk was about Apache Iceberg. So if you're interested in that, you can find that on our YouTube channel. Co-organizers for this event are Rahul and myself. If you are interested in giving a talk here at Data Engineers Lunch or a sister lunch, Cassandra.Link, feel free to reach out to me. My email is listed below. Also, if you're interested in sponsoring Data Engineers Lunch or Cassandra.Link, you can feel free to reach out to me as well. We are a part of Data Community DC, so no matter your race, gender, sexual orientation, everyone is welcome, and we expect the respect to be given to all. Data Community DC is built of a bunch of different organizations. We fall under Data Wranglers DC, so if you're interested in all the various events and organizations, you can find out more at datacommunitydc.org. So what do we cover here at Data Engineers Lunch? We cover everything from the ingress to egress of data and everything that happens in between. So a topic like Apache Arrow is going to be really interesting today to see how it fits into the realm of data engineering. If anyone's new here, say hi, hello in the YouTube chat. If you have a question, feel free to ask it in the YouTube chat. We're shuttling questions here for Alex. Obviously, please be polite and courteous to others, but if you have any information on the topic or if you have any questions, feel free to drop that below. Here at Anant, we design, build, and manage global real-time data analytics platforms surrounding Cassandra, Spark, and Kafka. So data engineering is a way of life for us. GW University helps provide venue space when we have in-person events. We also have some organizational institutional sponsors. If anyone is looking for a job or if anyone's hiring, feel free to drop links in the YouTube chat, or if they have any meetups, hackathons, conferences, or classes they would like to promote, feel free to drop links to those as well. Anant is hiring full-time, part-time positions, data platform operators, engineers, architects. You can find out more at careers.anant.us. Every Monday we have data engineers lunch, and every Thursdays we have Cassandra lunches. We have released our 9th free Apache Cassandra runbook. It's going to be going away soon, so get it while you can. We'll drop the link to it in the YouTube chat, and this one specifically covers getting started with Cassandra troubleshooting, some tips and know-hows when you're debugging, as well as starting and restarting the service if you get down node alerts or if your node tool status shows down normal, etc. So feel free to check that out. And with that, we'll hand it over to our speaker for today, Alex.
Hey, everybody. My name is Alex Merced, and I'm a developer advocate here at Dremio. You can follow me on Twitter over there at AM Data Lakehouse, always tweeting out content regarding the Data Lakehouse and all the different technologies around it. And you can find a lot of the articles and other content that we've produced over there on the tech advocacy team over there at Dremio at dremio.com/subsurface. That's articles on Arrow, Iceberg, and several other technologies. Now, today what I want to do is talk about Apache Arrow Flight SQL, a universal standard for high performance data transfers from databases. So the idea here is just basically we want to transform the way that different technologies transfer data between each other. So that way we get better performance, but also just an easier quality of life when it comes to interacting with our data sources. Okay. So in our agenda, we're going to talk about what if we could have for our data transfers. So like what would be the wish list of things that we would want to have in our data transfers day in and day out? What options do we currently have, and why aren't they perfect? And how do we get to something better? And what is Apache Arrow? Specifically, what is this big project, Apache Arrow, and what are its different pieces, and sort of how does it affect this whole data transfer picture? And what is Apache Arrow Flight, which is a part of the Apache Arrow project, and what does it do, again, regarding the data transfer picture? And then we go even a step further, Apache Arrow Flight SQL. And then basically, once we add all of these together, can we take it an even step further with an ODBC and JDBC driver? And with that, do we satisfy all those things that we initially wanted to have in our wish list of things for our data transfers? So let's talk about that wish list. What are the things that we wish we could do when we're transferring data from our favorite data sources to, when we work with them in our scripts, like let's say we'll talk about like a Python notebook, or if I'm transferring them to some other service, like what would be the ways I like to do that? I would like standardized APIs. So that way, if I'm working with like 10 different databases, generally the way I'm going to work with them is going to be pretty the same. I don't have to learn a new way of doing things every time I use a different tool. So standard APIs are nice. Okay. Now, you may be familiar with this when you're working with like ODBC or JDBC, but every time you work with a different source, even though JDBC and ODBC kind of provide you a standard way of doing things, you have to install drivers for every different tool that you use. So you use X database, Y database, you're installing different drivers, you're configuring any files and setting up all the right settings, which can be really, really frustrating and not the most pleasant experience in the world. What if we didn't have to do all that? What if there was one driver to serve them all? That would be amazing, right? Okay, what if those transfers were high performance? Okay, sometimes, we might be connecting the source, and depending on what our use case is, JDBC, ODBC may feel, not as fast as we'd like. So, and then also when it comes to sort of, again, JDBC, ODBC, as we'll talk about later on, was made a while ago. So it doesn't really help facilitate today's world of like parallelization, where we want many computers, clusters of computers, processing our processes, because we're working with very large data sets, petabytes of data. Okay, so we need a standard that can really facilitate that parallelization so we can get that performance, not only when we are transferring our data, but also when we are processing our data. Okay, something that's easy to implement. So that way, so if we have the standard API, it should be fairly straightforward for any additional database, any additional tool that wants to implement this standard API to do so. Okay, so that was another, these are all the things we kind of want to address in the Apache Arrow project. But again, up till now, up until the existence of Apache Arrow, pretty much the standard for transferring data from point A to point B has been ODBC, okay, and JDBC. And they were created respectively in 1992 and 1997. And that worked. Back in those days, pretty much the way we work with data was always consistently an idea of rows. So basically, you know, you'd have an array of rows that you're getting back every time you access data from a database. And basically, back in those days, it was really just one computer communicating with another computer. And all of this is really reflected in the way that ODBC and JDBC are designed. Okay, so you know, it doesn't facilitate a lot of what today's world is possible, and we're kind of stuck with this standard technology that kind of creates certain bottlenecks because we're generally working with columnar data. We're generally, you know, processing data in clusters. So we need to kind of, we want something that kind of works that way. And because JDBC doesn't, oftentimes, even if our data source is fast and our client is fast, we hit this bottleneck in the transfer of the data in between two spots. And on top of it, basically, like JDBC, again, every destination, everyone who uses JDBC, you have to implement your own driver. So like, you know, if I'm using Jeremy, I have to use a different JDBC driver. If I'm using, if I'm using Cassandra, I'll have to use a different JDBC driver. If I'm using Postgres SQL, I'm using a different JDBC driver. And I got to configure those drivers. And even though I have one tool that lets me connect to all these sources, configuring all these drivers can be not the most fun thing in the world. And again, it doesn't really work well when we have today's sort of, especially on the analytics side, today's types of workloads. Okay, we're working with very different types of data from very different sources because, you know, different tools have different benefits and we're using multiple tools. Okay, and then generally we're talking about the OLAP side, the analytics processes, where we're running analytics, not transactions. We generally want our data to be column-based. Problem is JDBC is row-based. So what happens? We request data from the database, which has the data stored in a row-based format, a column-based format if we're using an analytics optimized like data warehouse or data lakehouse or something like that. It's got to convert the data into rows so it can transfer it over JDBC. And then once JDBC gets the data all the way to the other side, it's got to convert it back into columns. And that's where you're really hitting this bottleneck, all this serialization and deserialization. So if we can reduce that, then we're going to see ourselves have a lot better performance. Okay, keep everything kind of in a consistent format. So again, this was fine back in the day when everything was row-based. But again, nowadays what we'd like to have is see everything column-based. So before Apache Arrow, basically your option was to do custom protocols, which that's fine, but that means like every database would have to kind of come up with their own custom columnar protocol. And each client would then have to create, you know, a client side to dealing with that protocol. So again, you're running into that situation where nothing is standardized. It's faster because you're reducing serialization, but it's not standardized. So you're having to relearn the wheel with each tool you have. So you end up in a situation where you kind of have to pick your poison. I could connect with JDBC and I can use the API that I've been used to, use the functions that I've been used to, and just do things the way I've been used to. The problem is, again, you have that serialization problem. That's going to be a bottleneck. Okay, and again, every server is going to have a different driver. So I have to make sure I configure those drivers. Or I could use the custom protocol, which is great because it prevents the serialization, it prevents the speed bottleneck, but everything else is not standardized. So again, I'm going to need to deal with this different way of doing things for each database, each data source that I'm working with. So that's not really ideal either. Okay, so what if we could do this? And that's essentially what Apache Arrow Flight is going to give us. It's going to give us the ability to take data from the source, say, hey, I want this data. And instead of having to convert it to row just to transfer it over, it's going to allow us to transfer the data in a column-based format. So it'll transfer over the wire in column-based binary. So that way, when it gets to the other side, it doesn't have to convert the data again. And that's going to save you a lot of time, and especially when you're talking about lots of rows, like you're talking about millions, billions of rows, you're going to see huge performance benefits. Okay, because basically, like the amount of speed you lose as you get, like when you get to like you're talking about a couple thousand rows, you're not going to see that much of a difference between JDBC and Arrow Flight. But as you start going and talking about like millions and billions of rows, it's a exponential difference. It's going to be like, the difference between receiving data in a couple seconds versus a couple minutes, or even longer. So Arrow, that's what the Apache Arrow project is going to give us on many, many different angles. So let's just talk about the Apache Arrow project as a whole. Okay, so the core of the project, the idea was to sit there and say, we all on the analytics side. So again, not on like, hey, the application's doing transactions and adding and subtracting users. There we want to still be row-based on the OLTP side. But what happens when we're doing analytical workloads and we're creating BI dashboards and doing machine learning, we're generally going to want the data columnar. And before Arrow, everybody was just kind of coming up with their own columnar format and creating their own, their own way of doing things, which meant even if you were transferring between two columnar places, you'd have to kind of serialize between their version of columnar and this version of columnar. So it would be to everyone's benefit if we all worked from the same playbook. We all had the same standard way of representing columnar data in memory. And that's what Apache Arrow did. It created an in-memory columnar format. Again, not a file format. That's what Apache Parquet does. Creates a standard file format for saving the data in a file columnar. But what happens when you load that file into your computer's memory? How are we going to represent that in the computer's memory? That's what Apache Arrow addresses is. Because it's a nice standard, fast way that everyone can use. So that way everyone's playing from the same playbook. And that way all our tools can interop better and perform better, because we don't have to be reinventing a lot of these tools over and over again from project to project, because we're working from a standard format. So the Apache Arrow project not only includes just the specification for what does the data look like in memory, but also includes libraries in several languages, okay, that actually standardize implementing Apache Arrow in your projects. So if you're doing a JavaScript project, you can just use the Arrow JavaScript libraries. You working in Go, you can use the Go Arrow libraries. If you're working in Rust, you can use the Rust Arrow libraries, or Java, and so forth. So this way you can actually benefit from that standard format, but you don't have to reinvent the wheel. The libraries are there, you just use it, okay? And again, there's generally 12 languages so far, but more are being added all the time. So it makes it really easy, regardless of what language you're working in, to be able to embrace Apache Arrow in your data-intensive projects if you're using columnar data. This was co-created by Dremio and Wes McKinney. And basically, there's been rapid adoption because it's definitely something that was needed. So you're starting to see more and more data projects. And a lot of times, as a user of a database, as a user of X and Y tool, you might not even realize you're using Apache Arrow. Okay, so for example, if you're using something like Dremio, Dremio uses Apache Arrow from top to bottom and how it deals with data under the hood. And that allows it to have several performance benefits, but you as the user don't necessarily have to worry about that. It just works that way and just takes advantage of it. Okay, so it just makes life a lot better. Okay, and again, this is being used across the industry, across several different tools, as you can see here with this rapid adoption. Okay, but the actual Arrow format is really just about how you represent the data and how you work with the data. Okay, so you're still working in this world where you have one computer running a process, okay? But what happens when we deal with data in a cluster? And I want 10 computers to all do a piece of this operation, or I have 100 nodes that should all do a piece of this operation, and then I have a client that should collect all that information at the end. Okay, we still don't quite have that. So then another part of the Arrow project came to be, and that's where Arrow Flight comes in. So while Arrow creates this format for how we represent the data in memory, Arrow Flight was okay, well, how do we allow different computers, different clients and servers, to communicate with each other in a way that facilitates things like parallelization, again, reducing serialization and deserialization, all the benefits that all these kind of issues that we want to deal with. Okay, so again, Arrow Flight, so Arrow is the format, Arrow Flight is the standard for how we transfer that format across destinations. Okay, so it's a general purpose client server framework. Okay, and it's done using RPC, so remote procedure calls. Okay, and the beautiful thing, if you ever done creating an API in gRPC or RPC, what's nice about it is that you create one standard contract. You create what's called a proto file. And then what happens is that the proto file defines all these methods that have to be defined and what they need to return and whatnot. So the actual standard API is very clear and very well defined. making it very easy for any additional server to implement the client, and for every server, to implement how they respond to the client. Okay, so essentially what would happen is that if you ever use gRPC, with that one proto file, if I'm like some database, some new database out there, and I want to implement Arrow, all I have to do is just take that proto file, in my backend, implement all those methods, so that way they work with my database's APIs, and then a Arrow client can communicate with it. They don't have to create another Arrow client. That same Arrow client can communicate with any database or any endpoint that implements that proto file, that implements that Arrow API, which is really nice. So that kind of leads us into the whole idea that, hey, we only need one client. There's no need for juggling drivers and all that stuff. And that's and it's, again, easy to implement because you got that nice clear API. Okay, it's designed for data in the modern world, so it's designed with the idea that, hey, we might have several computers processing pieces of this query. So in that case, hey, I need to go back and collect all those pieces. It has parallelization in mind. It's column oriented. Okay, it's built with high compressibility, so that way you can really handle a lot of data really quick. Okay, and again, here you can kind of see some differences in the benefits. Okay, so you can see here, like at 2,000 records, like I mentioned earlier, a couple thousand records, you're not going to see too huge of a difference between ODBC and Arrow Flight. But look, 5 million records, okay, ODBC is taking about 60 seconds, and Flight's still less than like a second. We get to 1 billion records, okay, you see that like you're talking about actually several hours to get the data from ODBC, while Flight, you're still talking about like probably there like less than a minute. Okay, and there's actually a video that's on YouTube where actually I run, I take a PyODBC call to an Arrow endpoint, and I do one with the Arrow Flight client, and you actually can see the difference in speed side by side. It's pretty insane. Like it'll be like the arrows like done like this, and then like the rest of the video is just waiting for the ODBC client to finish for the same exact query, the exact same number of records to the exact same source from the exact same client. So highly recommend checking that out. But bottom line is that because of the way the Arrow Flight API is designed, you can have parallelization. Because instead of just saying, hey, I want to run this query, and then it just immediately gives you back the results, what it does, it gives you a ticket, okay? And then what you can do is if you have this sort of parallelized system, the client knows, okay, hey, let me communicate with the cluster, and then I can pass my ticket to the different nodes and get each node's part of the process. Okay, so this way, instead of, again, having to kind of collect all your data, like all that data having to be sort of aggregated on the server side, that data can be then aggregated on the client side, so you can receive that data faster, even better. So again, you have all these like different methods that are built with that sort of possibility in mind. So we're a step closer. We're a step closer to kind of getting where we want to be. Okay, I have a standard client interface. So now literally anyone can use Arrow Flight and connect to any server that implements Arrow. Okay, so one client. Nice. We have a standardized server interface. Again, every server can implement that proto file, and their API is going to be able to work, that their Arrow endpoint is going to be able to work with anybody using the Arrow client. Okay, and now we're preventing unnecessary serialization. Okay, the only thing still missing is that it's not fully built. It's built for like point A to point B, but there's still some extra nuances when it comes to databases specifically. We would really like databases to specifically implement this Arrow Flight standard. And generally databases work with SQL. Okay, so the idea is like, okay, can we create like a standard SQL interface? So that way, when you're sending SQL, when you want to do queries, do SQL type work against the data, that you have this standard that makes it easy for any database to sit there and say, hey, look, not only can you connect via Arrow, but you can send your SQL via Arrow. We're going to be able to process that work. Still going to feel the way you're used to feeling. Okay. So again, right now, basically, the client's just sending an arbitrary byte stream. Server sends result. That's what that do get. Okay. And again, it's basically that server has to implement the standard. Okay, so we want to kind of standardize this even further. Flight is meant to serve tabular data, so it's really kind of thinking columnar data, but it's not really like thinking of any particular, the underlying database structure in particular. So stuff like what's the catalog in the database that tracks the different tables. It doesn't yet, just at the flight level, still doesn't quite have these things in mind. Okay, and these are the kind of things that ODBC and JDBC sort of had solved in the past, which is why they've been the standard for so long. Okay, basically under the hood, when you're using JDBC, ODBC, you don't even realize it, but basically that connection is asking the database for any kind of catalog information, making sure it knows exactly where that database is, and doing all these extra steps that we just don't have to think about. So they go a step further and they create Arrow Flight SQL, which adds the extra detail to the Arrow Flight API to kind of handle those other questions. Okay, so this is the client-server protocol for interacting with SQL databases built on Arrow Flight. So built on that standard, okay, we're going to build this transfer protocol. Okay, we're going to leverage the performance of Arrow and Flight, because again, Arrow is the format, Flight's sort of like the standard way of transporting data. And what it does, it creates a bunch of standard commands. So this is really where like that RPC API really comes into play. That allows you then that enables to do things with any data source, query execution, prepared statements, database catalog metadata to collect data from that database, SQL syntax capability, so you can pass SQL to it and do different operations, and that database can then, it'll just run that SQL and however it's implemented in that database. And it's language and database agnostic. So it doesn't matter, like, again, you have Arrow implemented in like 12 plus languages. That includes the Arrow Flight client. Okay, so the Arrow Flight SQL client isn't built into every single Arrow library yet. They're still like adding them as we go along. But the idea is that eventually every Arrow library is going to have the Arrow Flight SQL client built in. So literally all you have to do is just download the Arrow library, spin up the client, and you can connect to any database, no driver configuration, and you just send over your SQL and life is good. Okay, so you have a single set of client libraries. You're not having to deal with like 20 different client libraries depending on which source you're talking to, and it's going to be more performant. Okay, so that's going to be really cool. Again, no having to shuffle drivers. Okay, cool. And this is kind of like what you'll see, again, that whole RPC API, you see like there's all these methods that have to be implemented. So you can be like, okay, hey, you communicate with the server. So the client says, hey, I want to get info. So like it wants to get data on the tables. So it runs a get tables process. And then what happens is that info gets sent back. Okay, maybe it receives a ticket saying, hey, here's the ticket. When that information is ready, you can go turn in the ticket and we'll give you the information. So then you take the ticket that was received, you run a do get past the ticket, the database receives the ticket. And again, if you're imagining a cluster, you could be passing this ticket to multiple nodes on a cluster who are processing this in parallel. And then it's going to send back that data in that Arrow format. And again, it's transferring in that Arrow format, so there's no serialization, deserialization. So you're getting the benefit of that standard columnar format, which just working in columnar is going to be faster. You get the faster data transport, and you're getting all the standardization. It's just like a lot of things are just going to make working with data at this level much easier as adoption grows. Okay, but you guys get the idea. Basically, it's all about this sort of back and forth. Okay, I make a request to the database. The database sends me like a ticket and some information. And then I can go use the ticket to go collect the data from either one or many nodes, okay, to collect the data that I need or that I requested. Instead of me sending a request, waiting for the whole cluster to be done, and then for it to be aggregated on the master node, and then get this one big chunk of information at one time that's then serialized into rows and then deserialized, taking an extra long time. Okay, so it just speeds up the whole process by eliminating all these bottlenecks that existed with JDBC, ODBC. Okay, and here's just like a list of many of the different commands that exist with Flight SQL when you're doing those back and forth. And you can see the kind of information you can ask for. Okay, I mean, I could send like queries, like SQL queries, but I could also be requesting catalog information, schemas, all this kind of stuff that I can use then to do other optimizations or other types of operations. So far, so good. Okay, so now we have a standard client interface. okay, we have a standard way for databases to communicate within this interface. We have, again, a nice standard server interface. Okay, so that way, again, every database implements their server database the same way, and then every client can communicate and send SQL in a standard way. So, if you are developing a new database or a data type source, you just implement Arrow, and and then you never have to do it again. And that's going to give access to your database in like 12 plus languages. So again, you're not having to implement a client in each language. Okay, it's just, there you go. You have access to all the SQL clients or Flight SQL clients. And then if you are a user on the client side, if you use 10 different databases, you only need one client. And then you can just use any of the Arrow clients that are in the 12 languages that are currently available, and you're good to go to connect to all Arrow supporting destinations. So it's really kind of reducing this whole sort of thought process of having to work with dozens of libraries across dozens of languages. Like whatever language, whatever data source, you're just using the same tool. Okay, and that's nice. Okay, and it's fast. Okay, so that's also really nice. And again, we're preventing that unnecessary serialization. That's where we're getting a lot of those speed benefits on top of, again, the better columnar format when it comes to doing analytical type workloads. So keep in mind, this is something fairly new. So Arrow Flight SQL is fairly new. So it's going to take some time for it to get widely adopted. I mean, I think it was just like Arrow Flight's been around for a while. Arrow's been around for a while, but Arrow Flight SQL, I think they just made like the official announcement like very early at the very beginning of the year. So as far as that implementation of a lot of these tools, or a lot of tools implementing Arrow Flight SQL, that's still sort of a newer thing. But again, eventually the hope is that it becomes a standard. I mean, Arrows are to become quite standard, and Arrow Flight's gotten huge adoption. So it makes sense that Arrow Flight SQL gets that adoption, especially as all the language libraries get that part of the library built out. But what if you want to take advantage of Arrow now? You know that there's certain destinations, certain databases that you might be working with that have an Arrow support, but there may not be the Arrow Flight SQL portion of the library in the language that you're working in, or other factors. Well, okay, Dremio contributed to the open source community a really nice thing. They created a ODBC JDBC Arrow Flight SQL driver. So what does that mean? Yes, it's another ODBC and JDBC driver, but it's one to unite them all. So instead of having to install a different ODBC or JDBC driver for each database, for each tool, you take one driver, you configure that one driver, you just keep using ODBC and JDBC the way you've been using it, but that driver is built with Arrow Flight in mind. So under the hood, it's just doing all the Arrow Flight stuff. And you're just interacting it within the standard API you've already been used to. Okay, and basically you can just use that like today and just connect to things that support Arrow today without having to learn anything new. You just configure another driver and it connects to all the Arrow Flight supporting sources right away. And you get all those benefits right away. Okay, so they're built on type of Flight SQL. So you're just working with it as you would normally work with ODBC JDBC. And then under the hood, it's translating everything into Arrow Flight stuff and just doing that work for you. Okay, so and it's completely open source. So that's a completely contributed part to the Apache Arrow open source project. It's out there, it's for everyone to use, and again, it allows you to take advantage of Arrow Flight today with whatever data source you like, as long as it supports Arrow Flight, which is pretty cool. Okay, so back in the old paradigm, when you were working with just traditional ODBC JDBC, you would have to install and manage a driver for each database. Okay, so I want to go use Postgres today, gotta go install a database, configure it. Oh, I want to use MySQL today, gotta go install the driver, configure it. But with the Arrow Flight SQL ODBC driver, I just install that one driver and I can connect to any Arrow Flight supporting destination. Okay. Performance, again, the traditional ODBC JDBC drivers, they're row-based, which is great if you're doing transactional type database work. So again, on your application, dealing with like adding a user, subtracting a user, adding a widget, subtracting a widget, then yes, that's the way to go. But if I'm trying to get big amounts of data for the purposes of running analytics on it, and feed like a BI dashboard or a machine learning algorithm, then I'm going to want to do column-based transfer, because that's going to be the way I'm going to be working with my data in a column-based format. Okay, so you get the benefit from the column-based compression. You get the benefit from a lot of different angles if you're doing that type of work. Okay, and this kind of reiterates what I just said in the sense that there's times when you want to use Arrow. So again, Arrow Flight is really designed with optimizing analytical workloads. So if you're doing transactional workloads, those are going to still kind of stay within the old paradigm because that's what that's optimized for. But again, if you're going to be working with a lot of parallelization, which is going to generally what you're going to want to do as you do more bigger analytical workloads. Because again, analytical workloads, you're not dealing with like, hey, I want to grab these 3 rows. You're talking about, hey, I want to go grab 1 billion rows because I'm going to aggregate, sales for the last quarter and build a chart out of it. So you're grabbing a lot more data. So you're generally going to be processing that data over a cluster of computers, whether you're using Spark, you're using MapReduce, you're using some other tool to do that processing. Okay. But basically, bottom line is if your client is row-based, okay, then you still end up with this conversion there at the end. Okay, so generally when you're dealing with columnar data at the end, so like again, I'm working with that data and I'm putting it directly into like a pandas data frame, which is columnar, wonderful. Okay, but again, if I'm going to immediately convert that data into a row-based format, then I would have been better off with the traditional ODBC JDBC. Okay. Cool. So again, the idea is you generally want to think about what kind of workloads you're doing. So if you're doing analytical workloads, then you want Arrow Flight and if it's simpler, use the ODBC JDBC drivers for Arrow Flight. If you're doing transactional workloads, again, adding a row, subtracting a row, someone updating their profile, stuff in your application, then that's not necessarily what this is designed for. Okay. So kind of summarizing, at the very beginning, we're like, what if we could have all these things with the way we transfer data? Okay, what if we could have standardized APIs? Well, Arrow Flight gave you a standardized API. What if I didn't need many drivers? Well, with Arrow Flight SQL and now the open source ODBC JDBC driver, all that's pretty standardized. No need for many drivers. I wish those transfers were high performance. Yeah, we got rid of the serialization, and it's in that highly optimized Arrow format. It's really designed for not only representing data columnar, but again, designed to be easy to compress and easy to be fast. Not my best sentence, but we'll go with it. And then it's built for parallel data transfers. Again, it has that API that's structured to facilitate the ability to communicate with like a cluster of computers and get the data from multiple nodes. Okay, it's generally easy to implement. Okay, because you have that standard RPC framework. Okay, which just means, hey, I have to implement this proto file, which outlines exactly what I need to set up. Everyone can implement that same identical standard API on the server side, and everyone can use the same client on the client side. Okay, making it really easy for anyone on both sides to use and implement. Okay, cool. And then that's that. But again, bottom line is Arrow Flight really transfers the way that all of our data tools can communicate, especially on the analytics side, to all of our benefit. So it's a really cool tool. Definitely a project worth following. They do have like a Apache Arrow Twitter account. But again, my name is Alex Merced. You can follow me on Twitter at @AMDataLakehouse, constantly posting about Arrow, Apache Iceberg, Project Nessie, all sorts of really cool data lakehouse oriented technologies that really facilitate better analytics in today's world. Not just better, but when I say better, I mean faster and cheaper. So definitely follow me to learn more about that. And with that, I open it up to Q&A.
Great. Yeah, there is a question from the YouTube chat. So is Arrow Flight an implementation of protobuf/gRPC?
Yes, in the sense that it uses the gRPC framework. So if you go to the Apache Arrow documentation, there's actually a section on the Arrow Flight API, and you can actually see the protobuf file or the proto file. So it does send the data over. So I'm pretty sure when you're sending the data over via Apache Arrow, you are sending it in the protobuf format. So basically, you're sending it in that nice binary format. And again, you have those proto files that kind of standardize the API, and you can use that gRPC framework to implement the client. Which again, those clients are being built out in those standard Arrow libraries. So as all languages are, their libraries are being completed, basically you won't have to worry about building your own client. You just use the client that's built into the Arrow library. But you would still go through the same process implementing it for languages that are not covered by the standard Arrow libraries. So it gives it really that nice standard way to kind of expand its reach.
Gotcha. A follow-up to that would be, so would we need to do a new proto file every time we want to move to a new table, or does Arrow wrap all of that?
You wouldn't have to create your own proto file. Basically, the proto file just outlines the basic functions that need to be implemented on the database server. So from the user's point of view, you would just download the Arrow libraries and use those. It doesn't matter what table you're connecting to. It doesn't matter what database you're connecting to. Essentially, what would happen is you would just use those standard set of commands like get flight info, which would connect. So you would say, okay, hey, I'm connecting to this endpoint. You would do something like a get flight info, which would get the information from that endpoint, which would be like the list of tables, the schema of those tables. But it's not like you have to re-implement the API for each database. It's like it's already implemented. You just use the client and communicate to any database.
Gotcha. Great. I hope that answers your questions, Rahul. If anyone else is on the YouTube chat wants to drop any questions, feel free to drop them. Otherwise, we'll go ahead and wrap up for today. Thank you again, Alex, for joining us here at Data Engineers Lunch. Great talk as always. Looking forward to having you back again. And with that, we will go ahead and wrap it up for today. Thank you, everyone, for joining us. We'll see everyone next week. Take care.